Have you ever really stopped to think about what's happening inside the walls when you just flick a switch? Well, today, we're pulling back the curtain on this incredible, invisible force that basically powers our entire world. We're going to answer the big question, what is electricity?
You know that tiny little spark you sometimes feel when you touch a doorknob? Or how a dark room can just instantly flood with light? That's not magic, my friends. That is electricity. And we are going to break down exactly how it all works.
So, first up, let's get right to the heart of it. What is this invisible force, really?
Believe it or not, this entire massive concept, it all boils down to one simple thing: charge. At its core, electricity is just the presence of charge, or more importantly, the flow of it. But that just leads to another question, right? What in the world is charge?
And to answer that, we have to get into electricity's tiny little secret. We've got to shrink way, way down, smaller than a grain of sand, all the way to the atomic level.
See, just like any object you can think of has mass, it also has charge. And this charge comes in two flavors, positive and negative. It's kind of like the two sides of a coin, or the north and south poles of a magnet. This simple little opposition is the engine for everything we're about to talk about. Okay, so let's meet our first key player, the electron. These are super tiny particles buzzing around inside every single atom, and they are the carriers of a negative charge. Honestly, these little guys are the rock stars of our story today.
And of course, for every negative, you've got to have a positive. So meet the proton. It's another particle sitting inside an atom, but this one carries a positive charge. It's the electron's perfect counterpart.
And here it is, plain and simple. Protons are positive, electrons are negative. And just like with magnets, opposites attract. It's this fundamental pull between them that gets the whole show on the road. So, we've got these tiny charged particles. What happens when they actually start moving? Well, that's when things get really interesting. Let's talk about electric current. What happens when electricity is on the move?
So how does this work in, say, your phone or a flashlight? Well, think of a battery as a sort of electron pump. It gives electrons a big push, sending them down a path, which is usually a metal wire, something we call a conductor. As long as that path makes a complete loop, a circuit, that steady flow of electrons creates an electric current, and that current is what powers pretty much everything.
Okay, so we've seen electricity on the move, but what about when it isn't flowing? Sometimes it just builds up and sits there. That's the other side of the coin, static electricity, or electricity standing still.
Right. We know what happens when electrons can flow freely through a wire. But what if they get stuck somewhere? What if they get trapped on a surface with absolutely nowhere to go? Well, that's when you get that little zap.
And that is what we call static electricity. Instead of flowing, that electrical charge just builds up on the surface of an object. And this usually happens with insulators. You know, materials like rubber or plastic that don't let electrons pass through them very easily.
You've totally done this, right? It's the classic experiment. You take a balloon, you rub it on your jumper. That friction actually causes electrons to physically jump from the jumper over to the balloon. But since the balloon is an insulator, those electrons get trapped on its surface. Now the balloon has a net negative charge, and that's why it can magically stick to a wall or make your hair stand on end.
So we've covered electricity on the move and standing still. Now let's look at a really cool example of how we harness all this power in our everyday lives. Let's talk about powering our world.
To do that, we're going to pop the hood and take a look inside a regular car battery. It's a fantastic real-world case study for how we turn these tiny little ideas into real, tangible power.
Okay, so inside that boring-looking box, there's a bunch of stored chemical energy, just waiting. When you turn the key in the ignition, that chemical energy instantly converts into electrical energy, creating a powerful flow of electrons. That flow, that current, is what cranks the starter motor and powers up your lights and radio. And here's the really brilliant part. Once the car is running, a device called the alternator uses the engine's motion, its kinetic energy, to push electrons back into the battery, recharging it for the next time you start the car. It's a beautiful self-sustaining cycle.
All this technology feels so modern, right? But the story of electricity actually began a long, long time ago. Let's jump in our time machine and go back to find the very first spark. And I mean a long time ago. Believe it or not, our journey starts all the way back in 600 BC. The ancient Greeks were the first people to write about static electricity. They noticed that if you rubbed a piece of amber, it could suddenly attract light things like feathers. Now, they had no idea about electrons, but they were definitely seeing the effects of static charge.
And here's a fact that might blow your mind. We all think of electric cars as this super new 21st century thing. But the very first ones? They were built all the way back in 1832. That's right, electric vehicles were cruising around long before the gas engine ever dominated the roads.
So, after all that, what are the key things to walk away with? Let's boil it down. 1. Electricity is all about the movement of those tiny charged particles called electrons. 2. When those electrons are flowing in a complete loop, we call that an electric current. And 3. When they get trapped and build up on a surface, that's static electricity. Simple as that.
You know, our understanding of electricity has taken us from a simple, curious spark of static electricity all the way to powering the incredibly complex world we live in today. It really makes you wonder, as we look toward the future, what's the next frontier? What will we electrify next?